Let's just a quick roundup, just for a recap of what we covered before. So I think we discussed about Azure Storage, where we have blob, table, file, queue, and disk. And also we looked at the blob storage. We also discussed about the type of blob storage in that especially it is block blob, page blob, and append blob. These are three types that we saw. And also they're all primarily the blob storage aspect is something it's very similar to S3 in AWS, where you can store yeah, the blob objects. The blob objects could be primarily unstructured and binary data, which is like images or videos or HTML. So yeah, so any static data. So that can be stored in blob storage. The typical use cases we saw, like serving images directly on a browser, or like storing files on a for a distributed access, and streaming video and audio files by storing them on blob storage, then writing to log files. So these are the various common use cases. Yeah, one specific mention is this data lake storage Gen 2, which is primarily a big data kind of a solution, but it is but blob storage is now extended with the Gen 2, where it can also store a data lake related category of files also, where you want to store the raw data from various sources, you want to place it in a data lake. Then so this also will play a major role here. Blob storage can be used for that purpose. The Gen 1 version is not suitable for that, but the Gen 2 version supports this blob storage also. So, which is a primary use case for a big data solution. So, and the differentiation is the blob is generally for the most used blob, storing blobs and text, which is most of the use cases. But if you're looking for storing the backup images or tapes or VHD images, so virtual hard disk, when I say VHD, the virtual hard disk images. So page blob is what should be used, not the blob. The append blob is primarily it is optimized for the storing the logs, because from the name append, you can like all append is like updating files at the end, right? Yeah, this is a log primary use case for storing the logs. So there's a subcategory in this, which is not there in S3, for example. So these are all very specific in Azure side blob storage. And also we saw how this structure will look like, account, container, and blob. You need to create a storage account in that you can create container. Container is nothing but a folder, and then you can store some images there. Right. Then you have this extension, something like blob.go.windows.net. So this name should be unique. So my storage account, this is what the account that you create. So this should be something unique. And we also looked at what are the options that we have in moving data to blob. So I face, I mean, there are some questions on this space in the exam. Like they give a scenario and they will ask you which option you choose for this data migration. And they all come under the data migration category. So you have on-premise data. The scenarios mostly will be you have an on-premise data. And then you have to move that to Azure. So yeah, it is a storage question. So which option do you choose? So that kind of scenario I saw in the exams. So yeah, so these are all various categories which come under that. AZ copy is for copying data to and from a blob storage. If you want to do it programmatically using .NET specifically, then data movement library. But if if you want to use data factory, I mean, if like ETL kind of scenario, then if you use data factory, then if you want to use like Linux-based systems, then you have a virtual file system driver. So then you use BlobFuse. Then this is most commonly asked question in exam. So what is, I mean, if you have huge petabytes of data, you have to transfer it, and you have constraints in transferring over the wire, I mean over the internet. So then data box is the solution. So And import export is also, this is the scenario is importing large amounts of data, using the hard drives. So that is what import export. I mean, the scenario, I think these two are the exam. I saw questions around this in the exam. So petabytes of data, then data box. Then if you want to store large amounts of data using hard drives, like hard drives is like um, they will ship the hard drive. I mean, you have to raise a request in Microsoft site, and they will send you the Microsoft's hard disks uh, to your enterprise. I mean, they will post it, and then you will load your content into this into the Microsoft's hard drive, and you will ship it back to Microsoft, and they will load this data into the storage layer. So that's how this works, import export. So it takes time, but yeah, it can be done. But again, the hard disk will have a limitation, right? It can't go beyond terabytes. But if you are looking for a petabytes level of data, then you have to use data box. The scenario is like 60 terabytes of data, or 100 terabytes of data, or petabytes of data. Anything beyond, like for example, 10 terabytes, then data box is a solution. Um, Then, yeah, this one, access tier, we also saw we have a hot pool archive. So this also very important exam candidate question. So this hot pool archive are the three access tiers which are used. Which one you will use for what? So this kind of, they will give a scenario and they will ask you questions around this. Which access tier we use for this scenario? So the scenarios mostly will be like an exam. You have to store a lot of. You have data in storage, but you need to retrieve it very frequently in on-premise. That is scenario. And now we are moving to cloud. So what access type do you use? So if you have to use it very frequently, then obviously it's hot. But it's your cost is your important factor. The scenario, then you don't use it very frequently, then cool is your option. And other scenarios, like you have to store the data for archival purposes, or audit purposes. You have to store it, and you have to retrieve it whenever it is required for audit requirements or anything. Then for that kind of scenario, archive is a solution. And again, the cost, there will be I saw this question very frequently, where in the there is a cost associated when you are extracting the data. I mean, hot and cool will not have the cost for extracting the data. So, but whereas archive will have a cost associated for extracting the data, because you kept it in archive. So, it involves some effort in taking that data from archive and giving it to you, right? So there is some cost involved there. So that cost also has to be considered for into looking for cost aspect. Yeah, so that is it is cheaper, but you have costs associated for accessing the data. So that is what is mentioned here. So the archive is low storage costs, but higher access and transaction costs. Like you have some costs associated for accessing the archive data. So yeah, and the duration also is very common in exam. So what is the minimum storage duration that you need? So it is also covered here. So hot is like you'll get it immediately. You can access it immediately. It's hot. Cool. You have to store at least 30 days. So what will happen if you use this before 30 days? The answer for that is you can extract it. You will get the data, but you will be charged for 30 days for sure, because this is something that you have to pay whether you are trying to access it before. So that is one question that you see in exam. Um, so the 30 days is the minimum time that is required, and archive is like 180 days. So these are the things that we need to remember in this. Yeah, I think we covered all this thing. I'm just doing a recap. Yeah, file storage is what I think we started. I think we started in the last session. The file storage. Yeah, so this is another category. I think we covered the blob side. So now, I mean, images and videos are not the only kind of files, right? We also have text files or word files. So these are all, they generally use SME protocol in a real on-premise world. So, so they are industry standard SME protocol and NFS. Uh, there is one exam, one protocol which I saw, which is also covered, but it's not there in the documentation. But it is when I went into the and started answering the questions, I see FTP also will come under file storage category. So FTP uh, protocol is also SMB, NFS, and FTP. We should add that as well. So these are the three protocols which are used here. Um, uh, So yeah, especially when you see any questions on the protocols where they give a scenario and they say that this has to be accessed to our SME protocol or NFS protocol or FTP protocol, the answer is file storage. So this file storage is nothing but you generally is like external hard disk. So you're creating you're buying external hard disk. For example, I'm just giving a scenario. You're buying external hard disk, and you could connect to laptop A, uh, remove it and connect to laptop B, and remove it connect to laptop C. You can still access all the files in all the three laptops, right? So it's a similar category. So it is a mount is what we need to create. Mount is what like you're connecting hard disk to your laptop. So you need to create a mount of the file share to the virtual machine. So the virtual machine could be a Linux-based virtual machine or Windows-based virtual machine. So you have to create a file share in Azure and mount that file share to any virtual machine. So that is how it works. So so it's like this is also important from exam. The mounting is something which is very common in this file storage. When in a scenario, they will say that they have a they have a file share server on the on-premise world, and now they want to migrate it to cloud. And it's a Windows-based operating system, and they use a mount like external E drive or F drive. They will mount as a file share. And in Azure side, what is the solution? Answer is file storage. So so you have to use file storage for that case. And yeah, so you this file storage when it comes like can anyone access the file storage? No, it will have a AD integration. So I mean, Active Directory is the micro solution. So it will also have as an AD integration. Only if you have access, you could access that file storage. Not anyone can access that file storage. Right, and then yeah, the files will be. Of course, there are some issues, especially. I mean, if you see a hybrid scenario, so mostly people will be using this Windows machines on their on the on-premise world, but they want to store files. So, but it's a cloud solution, right? So for that, Microsoft came with a solution called FileSync. So where if you want to use this file server on an on-premise world, uh, so then there's always a latency issue, right? I mean, if you want to access a file, every time the file is talking to a cloud and getting that file. So which is there'll be latency issues. So just to avoid that, they brought a concept of caching. So it's an intelligent solution. So they do a cache and they use Azure File Sync is what is used for this scenario. So exam question would be something like they have some problems in accessing the files. They're using already file storage, and they realized that there is a latency issue in accessing the files, like especially the big files. If you want to access like files which are more than 10 MB or 50 MB files you want to try to access, then there will be some latency issues because it has to download every time from cloud, and this is the most used file. So I mean that is a keyword because so that way this caching will help you. So it is the most frequently used file. Then what is your solution? The answer is file sync. So um, So if you use file sync, what it does is it caches the most frequently used file into your on-premise world. So that way you can access as if it is a local file. So, and file sync behind the scene, it will sync this data to the cloud file storage. So that's how so that you get a faster access in that case. So that is a very popular exam question here. So, and serverless files. This also is now gaining popularity because they made this file storage as a cloud native solution so that it can support a distributed file system also. When earlier this distributed file system was not there. I mean, it is. I mean, I'm talking about before this cloud concepts all came. Everything was not running on a distributed file system. But now various VMs are running across the network in a distributed fashion. So that's where now this file storage also supports the distributed file system now, where serverless file shares. Serverless is also another feature, so both are supported now. Serverless as well as distributed file system feature is supported in file storage. Then yeah, this again the similar category file sync for hybrid scenario, which will primarily transform your Windows servers into caches. So you can, if you already have a Windows server which you're already using it for caching purposes, you can use that itself for your Azure File Sync. At the end, Azure File Sync is nothing but a caching software which has to be installed. So if you're already having some Windows server, you don't need to install this specifically. So you can use your existing server itself and use that software to cache it. So that is what is, if you're already using Windows server, then you can reuse it. That is so you get some cost advantage. Right, and then, yeah, migrate your file server easily with lift and shift. This is what is the advantage that they are now bringing into this, where you can just do a lift and shift of your existing file servers into the cloud. So you don't need to do anything. You can just use it just like that. So you can do a lift and shift of files to the file storage. So yeah, this is how the structure will look like. You'll have an account, and then you have in the account you have a share. You need to create a share, and in the share you will create a directories, and in the directories you will have files. So it is more or less similar, just that this is a new extra step compared to the blob storage. Like in blob storage, also all three were there, except this is something very unique here, where once you create a storage, you need to create a file share. So, but after that, you create directories and files. And then here, it is maximum of, I mean, up to 5 TB is the capacity but in one share you can max for 5 TB. But yeah, you can create many shares you want. But in one share it is 5 TB is the capacity. Of course, directories are optional. You can directly put files also. You need to create directly. You can create a file also directly into the file share. So and then max is the file size is 1 TB max. That is the limitation. And then, yeah, this is what I was talking about the identity, where anyone can access the file storage. Answer is it has an AD integration. So, yeah, you can use on-premise AD, or if you already have an existing Active Directory, you can use that. If you are not having on-premise AD, then something called Azure AD that you can use. That is one option. And if you don't have AD at all, or you're not interested in AD, then you can use it through storage keys also. This is also available. Yeah, and then here the deployment options. If you see, yeah, like mounting a file share is one deployment option, and file sync is another deployment option. These are two options that you have in file storage. Encryption, beside this. How secured is the data? Is it encrypted? Let's say you have a file which is very safe. You have to be, this has to be more secure. So you should also do the encryption so that someone can only decrypt it and only they can open the files. So security angle. So the security angle aspect, you get questions on AD and of course this encryption. Um, so encryption, we have two options: encryption at rest, which is by default in Azure file server. So all the files that are stored in the file server are encryption at rest. So, something called encryption in transit is also there, where the files are in movement. Are they encrypted? Like you're copying a file from your on-premise server to a storage. So the file is not copied yet, but it is in process of copying. So someone can hack during that time also. Uh, so so for that, there comes the encryption in transit. While the file is in movement, even there this is also encrypted. So that is what this encryption in transit means. Yeah, but for this the requirement is the client who is copying the file should be SMB 3.0 plus complaint. SMB is the protocol, so it should be 3.0 complaint. Then this transit feature can be enabled. So you should just, it is at the end, it's just enabling this feature, enabling encryption transit option. Yeah, that's about the encryption part. So the answer is it is possible to encrypt while the file is in transit and also when the file is physically copied at rest. Both ways, Azure is giving you an option for file encryption. Um, then comes the data protection. What options we have when someone tries to delete this file randomly by mistake? So, what protection options we have? Again, this was the exam question. Data protection is software. It's something that you have. So, even you delete, it's like a recycle bin in Windows. Delete it, still the file will be there in recycle bin. So, you can go anytime, go to the recycle bin and get the file back. It's similar concept, software. So, so you delete a file, still it will not physically delete it. It will be there in the soft delete section. You can anytime revert it back. So, of course, other option is like the storage can be corrupted, right? So what options we have? The like just like Windows operating system, even drives also can be corrupted. So the drive is corrupted, like if your hard disk is corrupted, we have to throw it away, right? But in cloud, we have the advantage of taking a backup and restoring the data from the backup. So that is what is data protection feature in cloud. And the third one, which is very advanced feature, where what if you let's say your file which is having a virus, right? So that can hard disk. I think the cloud world is going towards the security aspect. So where there's something called advanced threat protection that you can enable. It's something which is introduced very newly in Azure, in preview stage right now. So you can enable this feature. So it can, before it copies the file to the file server, it can even scan the file for any potential virus or any other malicious actors who are there in this file. So that will be cleaned up, or the copy will be denied. So that kind of feature is also available. And these are something very latest features in cloud. So you'll not get such features in, I mean, the on-premise world, you can get it, but again, it all comes with some additional effort and cost. But yeah, in cloud, you get this as just a ticking a feature. You can get these features. Right? Yeah, and then another question that you can get is what are the various storage types available? So these are the various four storage tiers available: premium, transaction optimized, hot, and cool. So it's all how you use the data in the file. So you have various options here in file storage. Yeah, this is what it is. The premium is primarily uh, premium from the name itself. It is premium, so it comes with the cost. So, but it has a feature. It will have better features. So it is generally backed by SSD, and you also get a low latency and a single millisecond I/O. This I/O is important aspect because uh, once you write a data to a file to a storage or read a data to a storage, I/O matters. especially when you write, it really matters. When you're writing a file to a storage, the better I/O, the better performance. So, with premium, you get a better millisecond I/O. So, like when you write a file within milliseconds, it will be the I/O will be written to a file storage. So you get a better I/O in millisecond level I/O is than premium version. So that's why it is more popular for databases or website hosting or development environments use premium. Transaction optimized is HDD, medium, and standard. Yeah, so it is not SSD, so not solid state drive. It is hard disk, pure hard disk. All these three are hard disk because they're all. That's how they give a better cost reduction will be there. The SSD is the costliest compared to a hard disk. So yeah, the transaction optimized, hot, and cool. These are the three options that you have in file storage. I mean, purpose is our transaction after the name itself. It is optimized for medium latency. You can't expect super latency, low latency like in premium, but it is medium latency. And also, it is more or less standard category. So mostly used option here in storage tiers. Hot, again, it is backed by HDD. Again, storage optimized. Again, for the purpose is general purpose file sharing. If you're storing the files, retrieving the files on and off, then this should be sufficient for you. And also backed by file sync. Cool is like only for archive solutions. You want to store files for archive purposes, then you can use Cool. That way you get a better cost advantage. So yeah, that's about this. I think before this, I think let's go to a demo and then come back. So probably I will show you the files. Okay, just to save time, right? What I did is I just created some files for you. So it is basically this is what the storage account. I think if you remember in the first session we had gone through what is storage account, right? So you can create a storage account. So this is, for example, this is the storage account that I created now. So in storage account, this is what I showed in the first presentation, right? So this, everything starts with the storage account. So inside storage account, you have blob, table, file, view, this. So yeah, so we're talking. This is a blob storage, and this is the file storage, and this is the tables and views. We'll go through that later. But this is what we are now talking about file share. If you look at serverless SMB and NFS file shares, these are the most commonly used protocols. So if you remember in this slide, we talked about once you create this is a storage account that you need to create. Once you create a storage account, next is like creating a file share. So I already create a file share, but yeah, this is how we create a file share. It just gives a name. File MB data. Yeah, this is where the types that we talked about. The premium transaction optimized sorted pool. So whatever we saw in this last year. Okay. So premium transaction sorted pool. So this is what you see here. So you can create whatever. Oh, this is already. Okay. So here I can choose whatever I want. I'm just using transaction optimized. I'm using file discuss. That's all. So that's what I need to create. Okay. So once you create a file share, this is where you can access your put your directories or files inside it. So you can add a directory. So I can create a directory and I can put a file inside the directory. You can upload, select some file name. Something. Overwrite if you want it. You don't have anything. So that's all. So we have a file here. So this is how you create a file share. And as you said, this is generally, as you said, this is generally used for mounting. Right? So this will be tied to a Windows server or a Linux server. So generally you will do a mounting. So for that mounting, yeah, so uh, you can come here. You have option primarily to mount this files. Yeah. So once I come here, in for example, Shamshare, this something you have connect. This connect, if you see, there are three variations in it, right? So Windows, Linux, and Mac. So you can connect to any Windows server, Linux server, Mac server, and you can use this. I just, for sake of time, I will just quickly, I created a Windows server. This is another Azure VM running on Windows. So if you look at here, the sample file that I tried some time back, but I will just disconnect this. So this is how you get a file drive. So this is a Windows server. Like C drive and D drive is there. Now we created a file share. Uh, like Sham share is your file server, the file share. So and let's say you want to mount this can you imagine that this is an external hard disk that you created. So what external hard disk, and you want to connect this external hard disk or a file share to a Windows operating system or Windows laptop. So you want, if you remember your Windows laptop, right, you once you connect using USB cable, if you connect the external hard disk, you get a new drive. It's a similar concept where you create a file share in cloud, and now you go. You need to run this PowerShell script. It's a PowerShell script. So that if you need to write anything, it will by default once you click connect, it will give you the script. And you need to select which drive you want to use. Let's say I want to use, so for the to use that drive itself. So copy this, open the Windows file server, open something here, PowerShell, open your Windows PowerShell, just copy this script. It will, behind the scenes, will try to connect to that file server, uh, and and will give you this connection added successfully. Now we see this Sham share has come here. So I can see all the files that this is now I mounted this drive, this file share into my Windows operating system. So if I go here, you can see the file here, the directory of file that I copied here. And similarly, if you copy, create a folder here, you can directly see that also here. Yeah, I can just I create a directory there. If I come back here, I should be able to see that directory to that I created is there. So yeah, that's all. So it is like you can access the server both from Windows as a mount, the mount network location. So and also you can use the same thing on here also. Same thing, same Linux as well. So if you want to, if you don't have Windows server but you have everything in Linux, it's the same process where this script available. You just need to execute that script. So you go to the audio section. So sorry, go to here, Sham share. You can connect. In the connect option, you have a Linux tab. If you are using Mac, then you have Mac. So and then it's also to mount a directory in Linux. So it is creating a mount folder, Sham share, and then using normal Linux commands to mount. So that's all in Linux. Those are the PowerShell script. Yeah. So yeah, that's what I'm going to show here. If you, yeah. Okay. So again, this I mean, most of us would have used this Azure files. I mean, file server is very common use case in our on-premise, right? I mean, you can think how this lift and shift are usage scenarios in Azure files. So these are the three slides which talks about the next three slides talk about the usage scenario. Um, Imagine that this is your on-premise. Forget about this side of it. This is your on-premise side. In on-premise, generally, if you're using a file share, generally your application will so some Java application or .NET application. So this will generally connect to a file server. Like for example, this is an FTP file server. So this file server, you have a lot of files like and files, logs, and all will be stored. So your application will generally your file server will be connected as a E drive or as a F drive or a Z drive, sort of. It will be connected to a drive, so your application can access it. This is the on-premise scenario, right? Let's say if you want to migrate this server to cloud, so that's why it's called lift shift. You can just lift the content and put it to cloud. So 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 in that case, I mean that's how easy it is made these days in any cloud vendors. So you can reuse. You just need to create some configuration. That's all on cloud, but you can very well use this immediately for your day-to-day operations. Let's say for this scenario, let's say you decided to move away from your on-premise file server to a Azure files. Okay, so what you need to do is you just need to in cloud you just need to go and create a file server, the storage account and the file share. Like for example, Sham share is what I created sometime back, right? The Sham share is there now there. Just as I showed in the demo, you just need to mount it simply to some other drive and delete this drive. That's all. So you can very well use it from day one itself. You don't need to have any complex functionality here. You can, and behind the scenes, of course, you can migrate this data also to your Sham share, for example. So behind the scenes, you can do a migration. So, but very well, it is like you can create it and use it very immediately. So there's no downtime required or maintenance windows required to it. It's not very complex. So you can straight away use it. So that's about the lift and shift aspect of files. Other usage scenario, very common usage scenario is the file sync scenario. I think I told you there are two options. One is mounting a drive. This is the first drive, mapping a drive. Second option is file sync scenario, where let's say you want to introduce a file sync because you generally access files very, I mean, you generally store very big files like more than 10 MB. But in this scenario, the problem is you are uploading, downloading every time a 10 MB or 50 MB file to the cloud and downloading it every time. So there will be some, it depends on your internet speed. It might take some time to upload or download a file every time, right? So that is a common pain point in cloud, because in on-premise you get a better latency because it is physically located inside your data center or within your network. So it will be faster definitely. But when you're bringing your cloud into this, replacing it, every time there's a data transfer happening between you and the cloud, right? So that takes some time. So just to avoid that pain point, Azure brought this file sync concept. So file sync concept is nothing but um, generally you as a client, either you can use an FS protocol or SMB protocol or FTP server protocol. So in either of these ways, you try to access your file server. So this is your normal Windows file server, Windows machine, and what you do is you install an agent, file sync agent in this. So you are mapping in Windows. There is a C, for example, C drive, C drive share or for a file share. So in C drive there is a folder called file share, and you are using that to copy all your files. Okay. So it is behind the scenes. Your this file sync agent is also installed on this file server, Windows file server. Behind the scenes, it is replicating or syncing the files to the cloud. So, so at the end, you are not really using directly the cloud. You are using the on-premise system, on-premise file server, but you are instead installing an agent in this server, which is behind the scenes syncing this stuff to the cloud. The advantage in this process is you get all the benefits of the data in cloud, so which may not be there in on-premise. Uh, so yeah, so that those advantages and also the high availability and the security and also the scalability aspects, everything you get in the cloud because your files are in cloud. But you are accessing huge files, so to reduce the performance problem, you can use your on-premise server itself. Just you need to install the software alone. So that's all. So behind the scenes, it will do the same. So for you, it is you're accessing a local file, so it is faster compared to downloading it from the cloud. Right. That is the advantage of this file sync. Clear? Any questions? So here, this is the caching concept is what is introduced here. So the most frequent access files. Because your latest copy is always there in cloud. So, but the most frequent files will be cached here. So that way your data is the most frequent access file you can get it immediately. So that is the advantage of file sync. And this is also a very common scenario now. On this, in the current world, everything is Kubernetes driven or container driven, right? So in container driven, also the container driven world, also you need a drive to store files. So because container is just uh, uh, a simpler version of your jar file or your .NET binary, right? Or Python binary. So there also you need a file share. So now this file share is now cloud native. So where you can, I mean, the software is cloud native, so that way you can link even your file server as the Azure file share also has a drive to your containers. So that way you can get the same advantage. So yeah, so you can, for example, in the I think we were not seeing the compute side of it. In the compute side, in Azure, something called Azure Kubernetes services are there, and Azure container instances are there. So these are the two uh, Docker-based or container-based compute environment. So for that, you can use your file shares also there. So yeah, that is. Because point is, we can now also associate a file share to a container. This is the summary. Earlier, it is not possible. Uh, so yeah, so you can use your persistent storage for containers. Like other files can be used as a persistent storage for containers. Okay, so any questions here? Okay, so if not, then let's move to the third section, which is the table storage. Table storage is is one of the uh, I mean this table storage is actually kind of now deprecated or deprecated are moving is moved to Cosmos now. But still people are using because it's a NoSQL store. So yeah, so this NoSQL store it's a NoSQL. You can the file is a so let's say it can be key value pair, right? It's a JSON structure and key value pair. So for if the data is in that format, then you can use your NoSQL container called table storage. So yeah. So again, from uh, this was before Cosmos DB came in the Azure. Talking about the initial days of Azure, Cosmos DB was not there. So at the time, this was the only storage option for storing the NoSQL structure. But now with this Cosmos DB is becoming super popular in the Azure world, where it is Cosmos DB is a uh, multi variety of storage structure. It can support SQL, NoSQL, Mongo, document DB, so multi model structure, schemaless completely. So schemaless structure. So that is more preferred now. But still, it is table storage is also used for legacy requirements. So yeah, from exam point of view, don't get much importance on this, but just that you know, this is also another option that we have. Um, so Azure Table Storage uh, is for NoSQL. When you say NoSQL, it will generally it is talking about we're talking about key attribute category. So it is a key attribute category of store is available with schemaless design. When you say key attribute, the key can be string, but attribute can be anything. The attribute can be a JSON, another JSON. It could be string or it could be semi JSON. It could be anything. So there's no structure for it. Also, it's called schemaless. So so it is a schemaless design and key attribute storage option in cloud. So and it generally stores a semi-structured data which is highly available, and also it can create massively scalable apps. So it can create a lot of scalable apps with this baby storage, and it is generally used for flexible data schemas. So you can create apps that require flexible data schemas because, as I said, the attribute can be in any form, right? So, so you have the flexibility to today when you are starting a project, you have a design in one form, in one way, but later when you go down the line, you realize that this is not data structure; it is a different data structure. It is not a parent relationship. It is like it's a flat structure. So your requirements can change in future. But the advantage is that in key table storage, you have the option to incorporate that design. So I mean, but whereas in your RDBMS kind of a structure, you can't change that, right? So you have to recreate the tables, or you have to work around on the hierarchies, parental relationships accordingly. So, but in NoSQL key attribute facility, you don't. It can change. It is flexible. You can change the data anytime. Um, and also it uses JSON to serialize the data. So everything is stored in table storage as a JSON data. Uh, and it can also perform OData based queries, which is very popular strategy in the Microsoft world. OData is very commonly used in storage requirements and for queries. So yeah, so this is where this is Azure Table Storage is used for. So summary: Table storage is a NoSQL key attribute store, schemaless design, and it is flexible. And it generally uses JSON to serialize the data. So these are the important things that you need to know. Again, coming to the common use cases, when you have to store terabytes of data, of structured data, and where it can serve a web scale, then you can use table storage. And this storing data sets here don't require any complex joins like a typical RDBMS. If you have to retrieve the data for a complex structure, then you need to do a lot of joins and foreign keys and or you may have to use stored procedures. So all those things are not required here because it is schemaless. At the same time, you can store a lot of data in one row or one column. Um, so yeah, generally it's denormalized structure. And yeah, quickly querying the data using a clustered index. So what is important here is this indexing and is always plays a major role, so that we can retrieve the data faster. As long as indexing is there, you should have proper index, then it can retrieve the data faster for you. And behind the scenes, it uses OData protocol and linked queries, which is very popular in the .NET world, WCF data services, .NET libraries. This is how it is used to access the data. OData protocol and linked queries are used retrieve the data using .NET. So yeah, so this is what a table storage. I mean, from exam point of view, is not very important to know because it's now everything moved to Cosmos DB. You get allocated some Cosmos DB more for 303 exam. So Cosmos DB and SQL Server are the two databases that you need to know. But this is coming at a
So
database.
this comes under the NoSQL, right?
Yeah, this is NoSQL. Yes, yes. Yeah. This is actually this is not really. I mean, it comes in database from my point of view. So I don't know why it is coming. It's classified as under storage, the basic storage. But yeah, but again, and then it is also database is also storage. So yeah, it makes sense. But for me, it is a database. It should not come here. But yeah, again, that's how Azure is configured. So, but anyway, now table storage is kind of even the Microsoft documentation itself. If you go to table storage uh, documentation, they will say in the first line itself to move to Cosmos DB. So, but for me, Cosmos DB is more costly on the other side because just for table storage requirement, Cosmos DB is costliest feature. But because it has other features which for a smaller use case you may not need it. For that purpose, table storage is still cheaper compared to Cosmos DB.
Yeah.
Right. This the structure in table storage. Same thing like we saw in blob storage. You need to have an account, then create a table. Under the table, we have an entity. So, for example, customer is a table, and customer tables can have many columns, right? People are giving us world. If you think it will have a lot of columns like customer name, customer email ID. So you can have any number of records under this table. So like rows, you can imagine this as a rows in a RDBMS. Similarly, address, for example. Yeah. So it's a table and entity. So that's how this is structured in a table storage. And table storage, the URL format, if you look at it uses table.core.windows.net. So that is the storage name is something unique. The storage account name. But it is appended with a .table.core.windows.net and slash followed by the table name. So that's how you can access the customer, for example. Let's say the storage account is Sham. So Sham HTTP sham.table.core.windows.net slash customers. You can access the content, the entity from this over the internet. And then the Cosmos DB table APIs are used. So like Cosmos DB, if you see Cosmos DB is also there here. The Cosmos DB is now at some point I think they will migrate this table API to Cosmos DB, but I think for now it is separate. But in Cosmos DB also you can create a table API. So there also it is available. So yeah, if you're creating the table storage in a storage account, okay, if you're creating it in a Cosmos DB, then you can access it in a similar way. So storage account, just that it is a Cosmos DB, so it's of core it will come as Cosmos DB, and Windows it's coming as Azure. Yeah, I mean the one thing which you need to notice, all the older versions will have Windows.net. For example, storage is something which was there initially when Azure started. I think just to give a history, right? I think initially it is not called as Azure. It is called as Windows Azure. Then they renamed, they rebranded it to Azure. So yeah, that's why you still see Windows in the older like storage and compute. You might see this Windows.net. But yeah, now they rebranded it to Azure. So Azure.com. So that's why this Cosmos DB which came later, but that you have Azure.com, not Windows.net. But yeah, so then here there will be table. Table is a collection of entities, and entity is a set of properties. So that's how this is typical NoSQL structure, nothing specific to Azure here. In any NoSQL, there will be something called a table, which is collection of entities, and the generally tables don't enforce any schema or entities, which means like in one table itself you can store all entities if you want. For example, customer itself probably can create. You can also store address section inside customer as a subcomponent. No, there's no hard and fast rule in a NoSQL world. You can create all the tables into one entity itself. It's up to you how you want to design it because it's flexible. And of course, if you want to think logically, it is good to separate it. Yeah, I can separate it. So, but yeah, well, one restriction that you need to keep in mind is that an entity in Azure Storage can be up to 1 MB in size. So that is one restriction. Because this can't the structure, for example, can't go beyond 1 MB. 1 MB is sufficient for you can store loads and loads of properties in 1 MB size. But yeah, but in Cosmos DB, if you're creating the same thing in Cosmos DB, then it is 2 MB in size. Okay, so that's about the table. So nothing complex here to know. It is simple functionality, and more it is moving to Cosmos. So yeah, at some point this might be migrated there. But coming to the here the storage, this is how you see this table storage here. This is table or data storage. You come here. You will create a table here. So this is how this access this URL. So and that's all. I mean, once you go inside, it is like you can access all your content inside from this. So like how you access your you can also access policy to this, and you can access you can add a policy like who can use what when. So this is something that you can give start time when this person A can use this table from this date to this date only. So you can add a policy to it so that that person can access this data only during this time frame, not beyond that. So you can add that access policies to it. So also it is something from this you can store all the contents. You can retrieve it every time. But if you see here, check out the premium table experience with Azure Cosmos DB. Here it is giving you. They're asking to migrate to Cosmos DB more or less. So this will take you to the Cosmos DB section. But yeah, I think it is good to know that this is also there, just from exam point of view. Right, the next is queue storage. For any questions here in this table storage? Okay, let's move to the queue
So,
storage.
has anybody used the table storage in the real application or something
Not me.
like money or somebody?
We haven't used actually. I tried it using Cosmos table, using Data Factory. I moved data like storing a JSON file and then pushing into a CSV using Data Factory. That's what I tried. But I used Cosmos. But Sham, probably that's one of the questions I wanted to ask you because you mentioned it. This is kind of a redundant in Cosmos.
No, not redundant in
But when
Cosmos. Redundant in
sorry.
storage.
In storage, sorry, redundant storage. That's correct. Yeah, redundant storage. But when I tried it in Data Factory, probably I think you can try it because when I tried it directly from storage, like blob storage, as a table, I mean, directly accessing as a table storage and storing a JSON file and then converting into a CSV, it didn't work. But from Cosmos, it worked. I don't know the reason, but this kind of. I don't know why, but yeah, I tried
Okay.
some.
Yeah. I mean, you can store any JSON structure here. I mean, it's a flat structure. You can store anything.
Right.
But yeah, the accessing part, probably the integrations with Data Factory, I don't know how it is done. Probably it is a dying storage option. Probably it is not supported maybe in data storage, Data Factory. But yeah, it should be possible from my point of view. But again, there is also one storage. But yeah, I don't know. Probably it is.
Because the question was actually in the underlying, storage layer, storing directly as a table at the table storage layer versus Cosmos. I'm not sure what is the difference. That's what my question was.
Okay. I see. The Cosmos. I mean, Cosmos is like it's a proper DB. Right? You can store. You
Yeah,
can consider that as a
NoSQL,
DB.
yeah.
Yeah, it's a NoSQL store.
Right.
So
Right.
so you get all the I mean all the investments is all going to Cosmos DB in the storage layer on in the Azure side. So you get whatever feature that you think is latest, it is all there in Cosmos, where you have 6 replicas of data, geo-redundant, then access it in very milliseconds level, and it can very low latency. All these are all super duper features in the database world. So they're all available in Cosmos, but table storage is not that. I mean, the reason why they don't want to give the same options in both places. Probably that's the reason they're planning to move this to Cosmos, because Cosmos is already
Right.
supporting this feature. But yeah, it's not that feature rich here in this storage world. But yeah, it is for a simple use case where let's say you don't want all that super duper features in Cosmos, because you have to pay for it also, whether you use it or not in Cosmos. So the storage cost, I mean the cost is high in Cosmos here. But whereas for a simple use case, this should be sufficient. So then you can use this. Yeah. I mean, I was reading an article in Cosmos DB. I think your monthly expense itself is $25 for a basic features. If you enable the basic features, $25 is your I mean, the minimum that you need to spend. So I mean, monthly $25 is a very costlier feature, because the storage and all you get for almost like $2 per month for a basic usage, but $25 per month is a considerable cost even for a basic feature. Yeah, so that's where yeah, for simple use case, this would be the best one.
Thank you.
Yeah. Okay. And the queue storage. So uh, this is a different variety out of the other three options, where this is um, it's similar to an asynchronous world like WhatsApp. I could relate queue storage is like your WhatsApp. Okay, so in WhatsApp, I'm just giving an analogy so you can understand this better. So in WhatsApp, right? So you send a message. So person A is trying to send a message to person B. Person A sends it, and he forgets and look into something else, right? I mean, he will continue with his work. On the other side, whenever person B is free on the other side, he will open the WhatsApp and he will see, and then he will respond, right? So there is person A and person B are not waiting for the message exchange. So they're sending it and they're doing their work, right? So for such kind of a use case where person can A and B can think as two applications. Application A is trying to send some data to application B, and it is not waiting for the response, right? It is continuing sending the message, and it is continuing with its work. So that is a use case, perfect use case where this will fit. So here for queue storage, you need two parties. And they want to asynchronously send data over, and data is transferred over. They call it something called message. So we get in a queue world, it is message. Like when if we have done work read in data structure classes, right? There will be first in first out. That is what is queue, right? So the messages will come in series. The first message will be served first, then the second message likewise. So it will follow the FIFO structure where first in first out. So you can think that it as a pipe of messages, and in the pipe you get every message will be queued, and so on one side of the pipe a sender will send a message to the pipe. Another side there will be a receiver who will be receiving that messages from the pipe, and it will be coming in first out pattern. So that is what this queue storage is. So this pipe is what we're talking as queue storage here. So and the messages. So in a pipe there will be messages, and messages will have a size limitation. So each message cannot 64 KB is the size. So each message will be of type 64 KB, of size 64 KB max. But in the pipe we can have millions of messages, There's no limit. We can have millions of messages, and it can work in the first in first out pattern. So from exam point of view, any question on asynchronous data transfer, the answer is queue storage. And this is most commonly asked question. Asynchronous, where when WhatsApp case, we think both parties are asynchronously exchanging messages. So no one is waiting for the other, like it's not synchronous. So that's why it's for asynchronous pattern, then queue storage is a popular storage option. So yeah, coming to this durable queues for large volume cloud services, that's where this queue storage is primary for, and the advantage is once the data is in pipe or the queue, you can access that messages anytime on the internet, like HTTP or HTTPS. You can access these messages. Um, and this queue size for a message is like 64 KB. So that is what the max size of a queue, of a message in a queue. And this queue can contain millions of messages, and and they generally they'll be backlogged, right? I mean, not on the other side, the person B could be slow in receiving reading the WhatsApp messages, or maybe 2 days he will not even look into the WhatsApp, but the message should be stored in the WhatsApp server, right? The message should not be deleted. So basically, in one side, one person is very active, on the other side, the person is not even responding, is very busy, or is not even looking into the messages. But if he is not looking into the messages, the message should be stored in the server. It can't be lost. So that is where this is a perfect example where the queues are stored and there will be backlog, and they should be processed asynchronously. These are the common use cases for queue storage, and the deep and they should be able to decouple the components, and it's primarily meant to decouple person A and person B. So they can be at different phases, but yeah, they can send independently messages. And it is also built for resilience, where if a person B on the other side is down, but still once he's back he can read from where he last left, right? So that because the messages are still stored in the pipe or the queue storage. So this is a perfect resilience use case, and all the microservices pattern nowadays, they all use this queue storage concept. So yeah, so this is a perfect use case for resilience aspect, where if your architecture is like splitting both applications A and B, which are talking to each other to be resilient, then the queue storage could be medium in between. So if architecture goes down, the messages are buffered, and they are naturally picked up by other message processing nodes, which maintains integrity of the workload. So that's what I said. Then scale for bursts. So suddenly, if there are, let's say, one person is super actively sending WhatsApp messages, like he's sending hundreds and hundreds of messages in WhatsApp. On the other side, he is not even looking into it because he's busy. So in that case, the load is high on one side, but on the other side, load is very slow. So in that case, right, you're not bombarding uh, with a lot of information to the other side. So they're all stored in this queue storage. So that's what it says. The scale of burst. So sudden info, if there is there, still it can maintain the queue length, and also this also can there's a limitation to this pipe right in between. So even this pipe will also can hold a limit of messages. But if your input on one side is going super high, then even this pipe also has to be made bigger, so it can store more messages. So that's where this elasticity will come there. So even this queue storage is elastic in terms like it can scale based on the queue length in which it receives the messages, the rate at which it receives the messages. So if you look at that, and if required, it can scale up to accept more capacity of messages. So yeah, this is very common. even though it's a very old concept, it's nothing new. This queue concept is very old concept, but yeah, every cloud vendor is giving their future for this because this is one of the most used microservices pattern. So um, yeah, this if you look at table storage. Yeah, in queue storage, it is storage account and the storage account name, and there will be a queues and the queue will have a message. So that is our storage account and queue. That's all. These are the two components that we have in a queue storage.
So, Chan,
yeah.
One question here.
Yeah.
So usually this kind of the thing that you described in the last slide, right?
Mm-hmm.
That is usually like if you take a product like MQ.
Yeah, exactly.
Yeah. So that is the actual middleware, right? Like that we are talking about, like basically asynchronous processing. But Azure is this is
Yeah,
storage,
man.
right?
Now middleware is all gone. Now all these cloud vendors are acting as a middleware.
Yeah, it's basically pulled in like this repackaging in a different form, but that's it. But I'm just the question is right, like so. This is just a storage, or is it like a type of storage, or is it the product itself? Like, what is it classified? Because it's coming under storage, but this is not a storage; it's a messaging.
That's true.
Middleware.
From Azure way, it is a storage. So I like this concept, even though it is not a typical storage, right? It is a middleware kind of a thing, right? That's what we all got used to. But as far as Azure wise, the product wise, since they categorize all this in one way, it's easy for them to provide the security aspects, and they have all the commonality of the maintenance of things. So they think it's just something you store at the end of the day. That makes sense. So that they could keep all their maintenance things in one of these product called storage product. So you need to have a storage account to do anything in Azure for all this. So through that, they could have all the commonality for maintaining things in one place. That's how they viewed it. But from the architecture perspective, it is basically touching the last thing whatever Sham showed was, right. That was a kind of a NoSQL. They put it also here, and also middleware thing. They also put it here. This is slightly different from even AWS or even Google. These guys are the only one who kind of came out with this concept. But from the maintenance perspective, it kind of makes sense. But beyond that, it just see once you do these things, all you're doing is an accessing through the API. So that's still the same thing from the end user perspective. It's all like how you maintain things. That's what they bundled it differently. That's it.
No, so just to be clear, right? Like, so what I am trying to ask is, if you're doing a lift and shift of an application,
Yeah,
that uses a middleware like MQ or some queue, right?
yeah,
And you put it into this, would it work out of the
yeah,
box,
yeah,
or you're
yeah,
just
yeah.
going to?
No, it will work. Even in AWS world, they have something called SQS. This is similar to the SQS. It will work. But if you really want to have the real performance of the MQ, even the SQS doesn't give you that kind of a performance. That's why they have a different thing called Amazon MQ. So yeah, so you have to conceptually it works. It basically gives you the loosely coupled architecture. You just put it there, and somebody will consume it, so that there is no weightage in between. So the architecture of loose coupling is there. But will this perform the way the real middleware works, like TIPCO or MQ or something? No, it won't. But there are these guys. What Amazon does was they figured it out. Instead of investing too much on the SQS, they came out with their own product called Amazon MQ, so that is having so that they can price it little bigger. So these are all little cheaper version of the thing. So when you really compare with the MQ or TIPCO, this is really cheap. But performance-wise, if you want, you have to pay a little bit more on this cloud guys. I don't know, Azure has something more on that thing, but AWS has that Amazon MQ thing. Yeah, it is coming though.
Yeah.
But to answer you, yes, this is where the things goes.
It's not a lift and shift category. So I mean, just like we saw in file share, right? So file share is a lift and shift category, but this is not a lift and shift category. I mean, you have to do some pre-configuration, and then you should probably test it, and then only should migrate. It's not just easy lift and shift. Yeah.
It's not like a standard JMS specification, right? Like this
No,
is
no, no.
Yeah,
their
It is
own
not compatible.
API. Yeah.
yeah.
No, it is not
That's
compatible.
what it is.
Yeah.
But the other one, what I told you, Amazon MQ, right? That is compatible. So that
That is they
yeah,
look
that is what they are
open source.
slowly seeing that.
Mhm.
You know, these cloud guys, you know what they do? They give you cheap so that people will come. Cloud is cheap. Cloud is cheap. Cloud is cheap. Now, if you want something better with the other side of it, you come to this service which is not cheap. That's how they come.
They sell the printer and then they get you in the ink.
Yeah, cartridge they make money, right?
Yeah.
Same thing.
Yeah, but I just want to show you that even this is whatever the open source world that is also now supported in Azure. For example, Azure JMS that we discussed on AMQP, right? It's very popular also. So those are all now coming into Azure. The announcing preview of Java messaging service. It came very recently for AMQP. So what I realized is AMQP is where it is more popular. In fact, it came in August 2020 only. Indian guy only is a program manager. So this Azure they call us the branding as everything is Azure messaging. So there's a new world that is coming Azure messaging. So they're now adding all the Java ecosystem side of the message queue components. They're also bringing that. The both of those is JMS, right? The AMQP is also mostly used. So they're all bringing into this, and the Java Spring world. Also, there are a lot of Apache Cupid is very now getting popular. So all these things they are bringing into the Java side of messaging standards. They're also bringing into the Azure side. So, but yeah, at the end, everything is conceptually same. But the questions, I mean, the usage will be different based on what you're already using it. If you don't have any existing use case, then you have a lot of varieties to pick and choose. But if you are already using something on-premise, for example, if you're already using JMS, then probably JMS on the, what should be used, so that you can do a lift and shift easily, or not probably a lift and shift, but probably your migration will not be as complicated as others. Yeah. So, but conceptually, everything will have a queue topic. The subscription, the sender, publisher. So all those things are all same. Yeah. So here, if you look at
So yes.
JMS.
Yeah, so I don't know. Means if the thing is right, like if you are fresh to the cloud, yeah, and then you have want to develop some applications, this is okay, which is not latency sensitive. But I mean, I'm surprised that they included it into storage, right? Like so that.
Yeah, that is true. I think this is these for me the last two items, even the table storage, which is why it is a SQL NoSQL storage, right? It is a logical DB component. Similarly, here this is queue is more of a messaging component. But yeah, but what I see is that if logically, if you see they're right where for a simple requirements, and then it is storage, right? So there are commonalities across all these things. If you see block, table, file, queue, everything. If you see the storage component is the concept is common. Uh, so whatever is common across all, you define all the properties here. Uh, you may or may not use one or the other component, but you can create an account which is common with all the default properties. But anytime you want to use, initially start with blob, but later you realize you also want a queue. Probably then you should create a queue and change the configuration for queue based on your project requirements rather than going with the default stuff. Yeah, but yeah, I think logically it makes sense, but I think these two are a different cup of queues and tables, right? These two are different cup of tea, which are odd man out in this category from what we see from other cloud vendors, or even for the on-premise world. But on the other side, if you think differently, it makes sense because it's also storage. Right. Okay. So let's continue here. Yeah. Yeah, so this is the storage, and it has a queue, and the format is you have q.core.windows.net. Again, this is the older version, so that's why you see Windows.net here. So q.core.windows.net. Storage, the storage account is similar to what you see. You need to create a storage account, and the next is queue. So queue is where the pipe that you're creating, right? So the last set of messages. So it will generally the queue name should be all lowercase, and message. The message max size here in queue storage is 64 KB. Special mention that yeah, from before version of 2017, the max time to live allowed is 7 days. Okay, I mean you can the messages will be stored in the queue for 7 days max. After that they will expire. But after 2017 July, so they introduced this the maximum time to live can be any positive number. You can give a number like how many days you want, like 30 days, 50 days. You can give that, or -1 if you don't want. Like messages don't expire. Like, it's permanent storage. If you want to do, then you can select -1, which means which indicates that messages don't expire at all. So it will be there permanently stored in the queue storage. And if the parameter is omitted, the default is 7 days. Yeah, so that is these are there's always a default setting available. If you don't give anything, then there's a default is 7 days. So if you don't want to expire it at all, then -1. Otherwise, give some number 30 or 20 or whatever. So that's about this side. So queue storage, if we go here, same queue storage account. You have something called queues. Yeah, here it is something, but you can add a queue here. Lowercase, yeah, I think you saw that, right? So, so we have this queue available. So inside queue, you can add messages to this. So you can just send a message. It is like sending a message to a queue. I'm just here. I'm putting how many days I want this message to be stored. Like -1 is like message never expires. Okay, here we have. I think now probably that message is now the documentation is not updated, but I don't know. This, oh yeah, this 30 days if you put, you get, okay. So 1 second and 7 days. Probably I need to revisit this. The expiry is, okay, here they have a category. So, but the 7 days, I'm just looking what is the max that you could give. Without this 30 days, you can come to 7 days only. Because 7 is the max, I guess. I'll revisit this. So what is the correct number? So looks like we'll change this. So yeah, but you can use a message explaining so yeah, so we have this message stored. I mean, generally it is not a thingy that you should do here. You'll generally use an application. So the application will generally send a message to this. So this message will be stored here. So you can similarly dequeue this message on the other side. So If you want on the other side, let's say now user A on WhatsApp had sent a message. Now the WhatsApp message has come and stored here in this queue. On the other side, when other person is reading this message in WhatsApp, and he is basically dequeuing it. So, but generally dequeuing is not done here. You will do it programmatically. So that is where this dequeue will help. So yeah, but if you dequeue it, the message is gone forever. So the typical queuing concept. But generally, this messages of adding a message to the queue or dequeuing a message to the queue, you will do using some program. But what you need is the configuration that you get it here. So and also you can add IAM messages to this. Like who can send a message? Yeah, that the sending a message could be an application, or it could be a DB, or it could be another Azure component. So it could be anything. So only you need to give roles and permissions to it. So only then the people with valid roles only can access it. So this is where this Azure roles will play a major role. So owner or contributor reader, these are the common built-in roles. But if you want, you can create your own custom role also. But yeah, then you will give access policy to this. Based on this policy, the messages will be applied, the rules will be applied. So, for example, you want to give this access to a particular person, so then you can say start time and end time. So only during this time that person can read the data. Nothing complex here. I can just show the key value pairs here for the message. So a simple queue concept, nothing fancy here. So you can access this from this. Right. So any questions here? I'll revisit this statement because I see this is a different story in the. Okay. So the next thing is data redundancy. This is very important from SLM point of view. I mean, this is also a very important concept as an architect that we need to know because I think whatever we saw so far is all the basic operations. But let's say you have to think about high availability. So then for storage, then these are important concepts that you need to know. So the same concepts what we learned in high availability, they apply here for storage also. But in storage, there is a special data redundancy options that you have, which you can use it in your daily life. One is um, like how this replication should happen. So I mean, when you say data redundancy, you need to create multiple copies of your data so that your data is not lost, right? So that way you can say that my system is a highly available system. So even for any disaster or anything, my storage is super secure. So in that case, how can you say your storage is data redundant or highly available? So the answer is you should replicate multiple copies, and creating multiple copies is easy, but it comes with a cost, right? So you can create n number of copies, but every copy creation it requires an extra storage, and you need to especially when you have to replicate it across regions, then it comes with the migration cost also or data replication cost also. So of course, all tied to cost, but at the end, cost is not the only primary category, right? You also need to ensure that the system is highly available. So what options you have in storage for that? So I mean, this section is very important. Please, if you have any questions, please ask because this is especially for people who are preparing in any exam in Azure. This you'll get a lot of questions in this space. Sometimes it confuses you also. Yeah, this one is the three options or the four options that we have is LRS, locally redundant storage, zone redundant storage, geo redundant storage, read access geo redundant storage. Typically, it's called as LRS, ZRS, GRS, and RAGRS. So locally redundant is if you remember that high availability story that we discussed before. So we have only one data center. We have only one data center for every use case. So so within the data center, you want to store, then there will be the local copy that will be maintained within a data center. It's called locally redundant. So it is redundant, but you maintain a duplicate copy, but the duplicate copy will be within your data center itself, because you have only one data center. But let's say you're ready to pay for more, and you want to store the redundant copy in a different availability zone. Then you should use the next version, which is zone redundant storage. From the name of zone, so which means so the copy that you're creating is not within the data center. It is across data centers. As you know, there will be three data centers, right? Within any zone, there will be three data centers. So a copy in one data center will be copied or replicated to other two zones also. That's why it's called zone redundant storage. Since it is copying data to a different zone, it comes with a cost, right? Because it has to do some extra work of migrating the data over the network. So that's why it is a bit costlier compared to LRS. Then now across regions, that scenario will come, right? That's why it's called. You want to be more resilient, right? And let's say the availability zone entire country itself is, let's say, flood affected or some other issue, then the data is lost there, right? So just to safeguard, it's good to store the copy in a different region altogether so that you're safe. So that's why it's called geo-redundant storage, where now the copy is getting stored in a different region altogether, not zone with a different region. And GRS, there's a variation, which is RA-GRS. RA is read access geo-redundant storage. The read access geo-redundant storage is a design pattern where the copy will be copied. Copy is copied to a different region, but you can access that data. You can do a read operation on that data. But here you can't do a read operation. It will be copied, but you can't access the copy that is copied to the other section unless if there's a failover. Only then you'll be having access to the redundant copy. But otherwise, you don't have access to the duplicate copy. You don't have access to. So it is copied, but you will not have access to the duplicate copy. That is what is geo. But read access, geo is like you get access, but it is just read-only access. You can do a read operation, not write. So that's why it is read access geo. So it is with these two, GRS and RA-GRS, when you get questions in exam. So if you want to read the duplicate copy, then you should always go for RA-GRS. Sorry, was it clear or any questions? I mean, since you already look at high availability, it should be easier for you. But in case, let's go further. In LRS, so data is replicated with a single. Since it is LRS is a local copy, so you will always get a simple low-cost replication strategy. It is within a data center, so always the cost is low and it's also simple because it's only one copy that you are copying. But the data and also the data is replicated in a single storage scale unit. That is what this LRS is. The ZRS, if you see the diagram, a file is coming. We're talking about storage here, right? So the blob storage, and in ZRS it is zone redundant. So there will be always three zones, right? AZ1, AZ2, AZ3, availability zone 1, 2, 3. So the data is copied over three availability zones. So the same file is copied across three availability zones. So that way it is addressing the failures of a network or cable. If this is down, let's say this availability zone 1 is down, but still you have a copy maintained in availability zone 2 or 3. So you have that advantage here. So yeah. So the important point you need to know is data is replicated synchronously. That's a keyword. Synchronously across the three availability zones. So it is synchronous copy. So it's not asynchronous. So which means there will be if you enable this, because it is synchronous, you have to wait. I mean, for let's say you're using an API to store this data, and you enable this ZRS. Your API will respond back with the 200 success status only if the copy is copied successfully in all the 3 places. Only then you will get a success response code for a API. Which means you have to wait because it is synchronous. So it will ensure that the copy is copied in all the 3 places, and then it will give you I'm done. It is success. So in let's say in one place it failed, it will give a failure response. So yeah, that's why it is synchronously copied across 3 availability zones. It is ZRS. Then I think, I think I'm to wait the third slide. I'm just preparing this before this slide, but I think we're also running out of time. So I think I will talk this in the next slide. This geo-redundant storage is nothing but it will replicate the data into 3 different geographies itself. So which means it will take more time. But the advantage is one region is down, still you have data copied in the other region. So yeah, I think let's continue this in the next session. Yeah. So
yeah, thanks, Shyam.
Yeah.
So in the next session, guys, come out with some other presentation, okay? Along with Shyam, so to spice it up. At least 10 minutes, 5 minutes, chit chat, brainstorm, okay?
Yeah. And one
Shyam,
yeah, please go ahead.
Yeah. So Shyam, the difference between GRS and the RA-GRS is in the GRS, so we have the read-write capability, but
not write,
in
read only capability. Not write.
Oh, no. I'm saying the difference in GRS we have both read-write, but in read access GRS.
No. You can't do write anywhere. Okay.
Okay.
The GRS is you can't even read.
Oh.
Okay. So
because okay, for example, why I asked this question is, for example, suppose if I have my applications launched across the globe, right?
Mm-hmm.
And suppose if you are you are accessing it from India and I'm accessing it from Canada, for example. So depending on the storage access, does it access from the the nearest location where it is stored, or how does it work from the storage point of view? That's what my question is.
Okay.
Yeah,
got it. So I think this is a feature. I mean, the question you're asking is there is always the storage account when you create. You are creating it across a geography. Right? So we are mentioning where the storage location should be created in East US or in West US, or so that is different. This is you're talking about maintaining a copy of your data for high availability.
I see. Okay.
Both are 2 different topics. Yeah. So here we're not talking about the accessibility from a different location. Here we're talking about if there is a downtime.
The data.
Yeah, exactly.
Copy of data, right? Basically.
Yeah, a copy of data. If your primary is down, the East US is down. If you have a geo-redundant, or a read access geo-redundant, only these 2 will work for you. Right? So because your copy is maintained in a different location altogether. But the reason why they are not enabling write here is there's a duplicate copy, right? Your primary is always primary. So primary only can change the data. This is all secondary copies. So secondary copies is meant only for backup purposes.
Okay. So that means in GRS, it is just a backup, but you cannot read in case of any disaster. You can restore it from the GRS backup. Okay.
Exactly. So that is what is this. It's a backup copy. That is what it is meant.
I see. Okay. Thank you.
Yeah. So I mean, I want to talk about a use case which in our office I think it's ours is the solution that I'm talking about now is it's purely on-premise, not on cloud. But with the knowledge of cloud, we found. I mean, at least I was primarily involved in this process, where I could give a lot of suggestions to the architect who was working on this. So the use case that I'm talking about um, is geo redundancy. Exactly the same thing. It's data redundancy, but it's called as geo-red. Geo-red is like we already have a data center in I'm not giving the names, but yeah, this way in one location in Europe, and also there's a recently we introduced one more data center. We introduced one more data center in different location, not in Europe or outside Europe. So, in Asia basically. So we have one data center in Europe and one data center in Asia. So we have a complicated product which so far is using only the Europe as the primary data center location. Um, Last week was a major milestone achieved where the copy where the second data center is also brought up in Asia, and the data is now primary. The data is getting replicated in both these places. So so the pattern, if you look at there, it is we followed. It's one of the very popular pattern where it is called active-active or active-passive. These are the two popular options that we can think of in the design pattern. If you look at here. So we have one data center in active. These are the various patterns that we have: active-active pattern, active-passive pattern.
Shyam, probably it could be good for next week, right? Fresh.
Yeah. Okay, can do that. It shouldn't take much time. I just thought since it is related, I thought it is. We can go through that
yeah,
detail
because we
next.
can go deep dive. That's what I'm saying.
Yeah. I think I will logically conclude here, but I think since we brought this topic, I thought it is relevant. But I will logically complete. When we deep dive into this next session. But the use case that we achieved is we took is active passive, which means active passive is like always primary will be active. Uh, there's always a copy that is maintained in a separate geography, which is acting as a passive secondary component, or also called as passive. So the secondary component, either this could be active also, or this could be passive also. So these are two design patterns that we had, but we took the second choice just because of the cost. So um, so now the primary is always primary. All the writes also will happen here. Read is anyway there, but writes also will happen. But in the secondary, you can do a read but not a write. So that's where this is more or less like a RAGRS pattern. So you do a primary in the storage. The primary data center will do a read and write. Uh, so read is not a problem, but you can't do a write here because this is always primary. So behind the scenes, what happens is once you do a write, especially a new writes, the data will be copied to the secondary DB. Here it is, and it is all DB, right? So primary will have a database and secondary will have a database. So behind the scenes, it is on-premise, not a cloud, but the concept is same. So you are maintaining a write. The newly introduced write is copied over to the secondary DB behind the scenes. So at the replication, we are closely monitoring the replication and seeing how this performs. Like there is always a latency involved here because the data has to be migrated from a different geography, but it is taking at least 5 milliseconds extra time to replicate, let's say, one record in a DB to replicate on the secondary DB. It's taking 5 milliseconds more. But when you talk, it's just for one record. But if you're talking about multiple records, there is it can go up, it can spike up. So yeah, but you always have an advantage of this is secondary. We're not going to use anything here. But if something disaster strikes, you can literally move to to secondary and make the secondary as primary. So yeah, so we were doing a lot of testing on how much time it is taking, and we're writing a lot of scripts to monitor this and other things. So it's very interesting actually. And we'll discuss more in this next week.
Yeah, sounds good, man. Yeah.
Yeah.
So, so my only request is, if possible, guys, come out. Some of you come out with one more session, at least for 5-10 minutes, just to add some variations to it. Okay.
Okay.
Okay, guys. Thanks.
Thank you.
Thank you.
Yeah.
Thanks. Bye.
Thank you. Bye.